to everyone and welcome to our cloud coaching session. Today we are going to talk about Prometheus and Grafana on Oracle Autonomous Database. We have the pleasure to have German Viscuso, who is the Director of Community Management within Oracle EMEA, today as a speaker for this session. I'm going to let German to tell you more about what we cover in this webinar. Keep in mind that we're going to start with a short presentation regarding the topic, and then you will see two cool demos. So you will have the possibility to test it yourselves. In case you have an OCI account active, feel free to go to your console, log in, and take this journey together with us. That was all on my side. German, over to you.
Okay, thank you, Violeta. Thank you, Tom. I'm really glad to be here, and we are going to have a session today that is very hands-on. So I hope you're ready. Get ready your OCI console, and let's get started. Okay. But first, before we go into the demo, I'm going to provide just a couple of slides to give you some context. Okay. So let me share my screen. Sec. Go to desktop 1. Share, that's good.
We can see your console now, German.
Yeah, perfect. Okay, and now let's open the presentation and go to presenter view. So can you see?
Yes.
Yeah, perfect.
All good.
All right. So this session is about Prometheus and Grafana for Oracle Database. And as you can see as a subtitle, I have DevOps plus DataOps. But before going deeper into what this means, just let me introduce myself. I'm German Viscuso, and I'm a member of the Autonomous Database team. And I have been running a series of webinars and writing blog posts, etc., about observability and database observability and what that means and how it relates to application performance monitoring, and how can we bring all of this together with typical and popular tools that everybody's using, like Grafana, Prometheus. A lot of you already mentioned that you're familiar with the technology, which says a lot, right? So today I wanted to introduce you to a solution for a unified approach of observability that we built at Oracle, and this is mostly coming from Paul Parkinson's team and collaborators. He created a great live lab that we're going to go through. It's a great project. It's using Kubernetes, it's using Grafana, Prometheus, Jaeger, which we will, take a closer look at because I saw that some of you are not familiar with it. So my goal is to leave you up and running with a unified observability solution over Grafana that you can later adapt to your needs. That's my goal, right? So the project observes microservices backed by autonomous databases. In this case, 2 autonomous databases. One of them is an order database, and the other one is an inventory database. And the microservices use case or demo is called GrabDish. So it's a hypothetical place where users are placing orders for food, right? And you have an inventory of food, etc. Very simple. So you need to be at least on a fresh OCI installed with at least on the free trial, okay, to be able to run it. And you will see that I will run all of these on the free trial. I actually have a little bit more than $200 in my account right now. So it's fully free trial. So most of you are already familiar with autonomous database, but this project will be running 2 autonomous database as the underlying, let's say, data store. Okay, so what is autonomous database? For those of you that are not familiar, it's basically the Oracle Converge database. So it's an Oracle DB engine, but it's running in the cloud, right? So it's running in the cloud, and it's adding a layer on top of machine learning that allows you to basically not worry about a lot of the things that the typical DBA will have to be doing with the database, like this autonomous database provides self-tuning capabilities, self-securing, self-patching, etc. So a lot of the tedious work is already being done for you. So this database is not only great for mission critical applications because there are big customers behind and using autonomous database, but it's also ideal for demos and for workshops like this because it can be deployed like easily, and it does everything for for you, basically. So you just need to provision it within the OCI cloud, and you have a full-blown Oracle database up and running, plus all these machine learning layers running on top. Okay, so that's autonomous database. Now, observability. Okay, what do we mean when we say observability? This is a very hot topic today, right, among developers. All of them are dealing with, to some degree, with observability. Either it's the app, either it's the database, or there is microservices. We have to be monitoring what's happening, and we want to keep a close eye on those metrics, and a close eye on when we're deviating from what's going on. So the three pillars of observability were laid down in a Twitter blog post. The engineers at Twitter created this blog post in 2016, where they said the pillars of observability are metrics, tracing, logging, and alarms. There was a fourth pillar in that description, but basically that's something that is generated by all this, three pillars. So the alarms, it's something that you do on top of this to basically get notified, etc., etc. So these are the pillar metrics. Metrics, we're talking about, what's happening with a specific service, like CPU utilization, those types of metrics. Usually the services send telemetry. When we say telemetry, we're talking about data that is being sent by a service, and there's some sort of collection mechanism for that telemetry. It can either be a full-blown monitoring service, like the OCI monitoring service that we have within OCI that is collecting telemetry from the services. It could be a Grafana-based solution like the one that we have here that is basically collecting metrics from the database and using Kubernetes cluster, etc. And then we also have logging, as you can see here. All of these services are producing logs, and the logs are very interesting, but they're usually difficult to digest, right? Because you might have really big logs, etc., etc. So you will see today the solutions, how we're using specific keywords to actually be able to tap into logs and go from the metrics to and going through tracing and into the logs. So tracing, the last of the pillars. Tracing is probably the most complex because it allows you to have a horizontal view of what's going on. Suppose that you have a request that is coming from an application, and that request ends up touching the database and doing a specific operation within the database, and that fails. You probably want to have a horizontal view of what happened from the very beginning, which is what the user was making the application, all the way going down towards the database, right? And for that, you need a trace, because you probably need to look at the specific operation, and that within the tracing, lingo is called like a span, something that is happening, or a specific request, etc. And you might want to go and correlate that problem to a specific log within the database, for example, to give you an idea, right? So that's the magic of tracing. It allows us to have a horizontal view that is maybe a request scoped or request specific. Okay. All right. So the last one, before we go into the demo, what I'm going to show today is the solution that we call Prometheus Grafana for Oracle, that allows you to run all of this that you're seeing right now on the screen on a Kubernetes environment. So we have a Kubernetes environment that is maintaining a set of exporters that will export these logs, these metrics, and this tracing information from the autonomous database. And you will see later that this could be applied to any Oracle database. We're not limited to autonomous database, but the demo is using autonomous database, okay? So we will be exporting all this information that we will extract from the database, and you will see how we do that, because there are a set of views within the database that are performance views that give us a lot of that information. We are going to massage that info and those metrics, etc., and put them in a format that is easily digestible by Grafana. In the case of metrics, we are going to generate a Prometheus endpoint. In the case of logs, we're going to use Grafana Loki, which is like Prometheus, but for logs, okay? And in the case of metrics, we're going to use Jaeger, right? So that's that word that we used there in the poll initially, Jaeger. Jaeger is basically what you need to have an open telemetry-based standards for tracing. So tracing has to be in a format that is familiar, that it's open, that it's standard, and it can be digested by Grafana, okay? So that's what we're talking about when we say Jaeger, okay? And we will configure this ourselves, and we'll see all of this, working. So what are the use case? You might want to do troubleshooting of this, microservices running on top of specific databases. You might want to do performance tuning. You might want to set up alerts, et cetera, et cetera. So this is Kubernetes based, but not only the observability solution is Kubernetes based, but also the microservices that we will be running, which are based on Helidon for the GrabDish the GrabDish demo that we're using as an example, they are also containerized, right? And you'll be able to see these containers basically supporting microservices, okay? All right, so let's go into the demo. What we're going to do right now in the demo is this.
Herman, sorry, I'm just
yes.
interrupt you quickly. I'm just going to turn off your camera because your sound is getting a bit gritty in places, okay? So,
okay, no problem. Go ahead. Okay. So what we are going to do is just follow this configuration, which is the initial configuration. And when all of the project is being deployed, that will take around 15 minutes to give you an idea. So we will come back to some slides, give a little bit of more context of how these exporters that are supporting metrics, et cetera, are working. And then we will come back to the demo to wrap it up, okay? So if you're watching this, you might want to later, not right now. You might want to pause and just follow this. Otherwise, just follow along. Okay. So right now, you can go to the OCI console and follow me along. All right. So let's do that. Let's go to the console. Okay. So first thing that we are going to do is take a look at the limits. So basically, you should not have autonomous databases running because you probably have a limitation there. I think the limitation is 4, and we will be using 2. So make sure that you don't have a limit there. So we could go to autonomous databases, for example, here and see that we have none. Okay. My recommendation is to create a compartment. I created a compartment called workshop. Okay. So if you type compartments here, you can click on create compartment, which I already did, and create one called workshop or project or whatever you want to call it. And we will deploy everything there. And that's make things easier if we want to wrap up things, basically destroy resources, etc. I'm going to work with this compartment, okay, called workshop. Another very important thing is that you should have no more than one auth tokens here in the profile. I'm going to the profile, clicking here on auth tokens. I think that the free trial is limited to 2, if I remember correctly. We will create 1 now during this project. So if, for example, you have 2, it's going to fail, okay? Another very important limitation is OKey clusters. So, the Kubernetes clusters. This should be empty because if you're on the free trial, unless, of course, you have a full-blown account where you don't have those limitations. But if you're on the free trial, I think that you're entitled to create 1 OKey cluster, and we will be creating 1. So this will be verified during the setup anyway, and the system will tell you, okay? But basically, this should be empty if you're on the free trial, okay? All right, so the system will be deploying a lot of things automatically using Terraform. So let's go to the Cloud Shell right now. I'm going to click here on Cloud Shell. If you are not familiar with Cloud Shell within OCI, this is a bash command line that can operate over all of the resources in this tenancy, okay, or in your tenancy. And the really nice thing is that it comes with the OCI CLI pre-configured. So you can run the OCI CLI directly, okay? So let's wait, it's attaching right now. It's connecting, okay. Okay, I want no tutorial, no, okay. So what we're going to do is we are going to, let's go bigger, okay. We're going to create a GrabDish directory. We're going to cd into it, okay? We're going to place the project here, okay? So we are going to clone the repo right now. Typically, I would clone the project and just if you want to follow me right now and you want to take a look at what we are doing in detail, I'm going to put it here in the CLI. You can follow this short link here, bit.ly unified minus ops. Okay, so that's the live lab that we are following, and we are doing lab 1 right now. Okay, so take a look at that short link here if you want to follow. Otherwise, you can just follow me. Okay. All right. So what we're going to do right now is we're going to clone the repo for that live lab, and we could go ahead and clone the original repo, which is this one here. Just going to put it here. Okay. But there's an issue with the one file that has like a wrong Terraform provider. Okay, so we could clone that one and make the modification ourselves, or we could just clone my repository, which has a fix for that specific error. So I'm going to clone mine, but you can just go ahead and clone that one and basically fix an error in one file. I'm going to clone that. So probably in the next couple of days, if you're going to try this in the next couple of days, you can go ahead and clone the original repo. Okay, so I'm going to do that. Okay, I'm going to clone a branch. I have a fork of that repo and a branch where I fix that problem. Okay, so git clone -b Terraform provider revert, which is the branch, and my repo for the same project. Okay. All right, so we clone the repo. Now, the nice thing about Cloud Shell is that you have access to OCI. So the setup is going to ask for the compartment OCID. And for example, if you do this, like OCI compartment list, without the need to authenticate or anything like that, you are listing the compartments here. So and you can basically grab the ID of the compartment. This is the workshop compartment, and you can grab the ID straight from here. So I'm going to copy this, okay, because I'm going to need it. Or you can go to the console, obviously, and go to compartments and take a look at the OCID. All right, so give me one sec. Perfect. So now I'm going to run setup. But no, before doing that, I'm going to source some environment variables. Okay. So let me do that. This is very important because you need some shortcuts, etc., etc. So before running setup, make sure that you use this source. Okay, source environment. You will see that there are shortcuts, commands, etc., etc. So now I'm going to copy this again because I need that OCID, and I'm going to run setup. All right, setup. So you will see that it's asking me, confirm that you have OK clusters. I told you we are using 1 on the free trial. There's a limit to 1, so please confirm that. I'm going to hit return. It's going to check the limit anyway, but I just hit return saying, yeah, it's okay. I have no OK clusters. Please specify the compartment where you want to run the project, and I'm going to paste that OCID there. Remember, if you run in this OCI CLI, you don't have to copy this ID, which is the compartment ID. The one you have to copy is the one that just says ID for the compartment, okay? And that's the one that you get from the console anyway. Okay, I'm going to copy that. Okay, pasting. And now it's saying, please enter your OCI user ID. So I'm going to go here. If you go to profile, my profile, your user OCID, you can copy it here. Post it, copy. Okay, copy. And I'm going to paste it. All right. That's what I'm doing right now. Let's wait. Let's hope everything is okay. Remember, we are live here. Let's see. Okay, so it went well. Now it's asking for passwords to the database. It's going to ask for 2 types of passwords, one for the database and one for the front end of the microservices. Okay. So I'm going to use the same password. I'm going to just copy a password that I have here, which is you can use the same one. I use this one only for this workshop. It's workshop 1234. so it's workshop exclamation mark 1, 2, 3, 4. I'm going to paste that here, enter, and I'm going to use the same one for the UI. So you can use different passwords, you can use the same passwords, etc., etc. Take a look at the limitations, like the number of minimum characters, etc., etc., etc. So you will see this that says Lab 7 building, and this will take around 15 minutes. For me, it takes 15 minutes. Okay. So what this is doing is setting up all the infrastructure within OCI using Terraform scripts. You will see that the OKI cluster is being created, the autonomous databases are being created, the auth token are being created. So everything, all the infra is being set up for you, and this is fully automatic. So the system right now is monitoring whether those resources are there. Since they are not, it's entering a loop, basically waiting for resources to be available to create the next resource. All right, so since we have 15 minutes, so let me just put a timer here so I know when this is done. We're going to come back to the slides and give more context, and then come back and finish the demo. Okay. All right. So let's go back to the slides. So we did all of this already, just the demo setup. So as I told you before, this is going to deploy Grafana, Prometheus, the databases in kind of a container environment. Obviously, the databases are autonomous, so they are within OCI. They are not running within containers. In this specific architecture, they're running within OCI. But the system is clever enough to be able to connect to databases that are running as containers. You might as well be running 23C within a container here, or database services. So the system can also connect there. But we are going to deploy everything within that architecture, within that containerized architecture, and within that OKI cluster. All right. So you might be wondering, what about Grafana plugins? If I want to use Grafana, I could just go ahead, go to maybe Grafana Cloud, start my Grafana instance, click on Add Data Source, and type Oracle. And if you do that, this is what you will get. You will get the Oracle Database plugin, which is maintained by Grafana. It is commercial. You have to have Grafana Cloud Pro. You have to pay $25 per month to have it running. And this plugin is interesting, but it basically allows you to connect to your Oracle database by establishing a TCP connection, right? So you have to be careful because it allows you to run unmodified SQL. So you would have to craft all those queries in order for you to create the dashboards within Grafana. So you have to decide what kind of SQL you want to run in order to show that within a dashboard. You have to create the dashboard, etc., etc., etc. Okay, so this is nice, but it has some security concerns because it's establishing a TCP connection. For example, if you have a database that is within a private network and you're using Grafana Cloud, then you have the issue of how to connect from Grafana Cloud into that database, how to maybe whitelist the Grafana Cloud Service IPs within within OCI. Maybe you have to create like a bastion connection in order for you to connect, etc., etc., etc. So this solution is not what I wanted to show you, and it's not addressing a specific problem that I'm going to mention in the next slide. Okay, so you also get other plugins within Grafana. You get the OCI metrics plugin, and the OCI metrics plugin is built and maintained by Oracle, same as the OCI logs plugin. These are all by Oracle. They are open source. They allow you to connect to OCI, but they do not allow you to connect directly to the database. So this OCI metrics plugin will be connecting to the OCI monitoring service, and it's a great way for you to visualize what's happening with multiple OCI services, including autonomous database. Okay. So same for the OCI logs plugin, but this is not solving the fact that we want to look at those performance views within the database to see what's going on and tap into the the metrics that the database is generating. This will basically allow you, the OCI metrics plugin will basically allow you to take a look at the metrics that are being exported to the OCI monitoring service. And a lot of services export those metrics, like Autonomous Database, for example, but they don't export all of the metrics that you can get from these views, for example, in the database. All right. So I said that this is not addressing the problem. What is the problem, and what is the solution? Developers are using a lot of tools to do application performance monitoring. Developers are using Grafana, are using Prometheus, etc., to monitor the application, but are using different tools when they want to monitor the database. So there's not a clear path or a clear way to stay within Grafana, for example, if you're familiar with it, which doesn't mean that there are no other ways. Like, for example, if you go to the Oracle observability and management services, you can do all of this. You can do application performance monitoring, you can correlate that to database, et cetera, et cetera, et cetera. But I wanted to focus on Grafana because a lot of developers are using Grafana right now, have already set up their dashboards and they're very happy using it. And they say, hey, well, what about the database, right? So that is basically the problems. These tools are being used for specifics, but there's no really nice way to say, okay, I want to combine what I'm doing to monitor my app with monitoring my database, and I want to do tracing via Jaeger to maybe go from the applications all the way to the database to see what's going on when I see a specific problem. Maybe I set up an alarm, et cetera, et cetera. And I want this solution to be microservices friendly and container friendly. It has to be something that works within OKI clusters or any other type of Kubernetes clusters, and gives me the possibility to be running there and gives me the control, okay? So the solution is this framework that I'm presenting today for specifically if you are a Grafana user, and if you like Grafana, this solution makes a lot of sense because you already have expertise there. And so we call this a unified observability solution using open telemetry, tracing, et cetera, et cetera, et cetera. All right, so how did this start? What was the beginning of all this, effort? So we have something really nice within the Oracle database called transactional event queues. This is also available in Autonomous Database because it is an Oracle database behind the curtains. So this is really nice to do event propagation and persistence events. Some people use this as a direct replacement to Kafka, and I'm using Kafka brokers, for example. And it comes with all the advantages of keeping things closer to the database. Like, for example, if you are emitting an event where something is happening within the database, you can do that atomically because it's happening within the database. So, for example, suppose that you change a specific record, that there's a new, for example, a new customer being created within the system, and you want to emit an event with TQ, you can make sure that that event will only be generated when the customer was actually created, because it goes, everything goes within that specific transaction. Okay, so the idea was to say, hey, we need a system to monitor those events, because we have events that are being queued. Suppose there's a queue of all of these events, and events that are being dequeued, which is when the consumers are basically, reading those events and consuming those events. So there's like kind of a queuing and the queuing ratio, or queuing and the queuing, performance that you have there, and you might want to monitor that. So this is how things started, and there was a Docker configuration being established here to actually export this information from the views that are in the database. There are views, and we will take a closer look at that, that gives you the performance of this transactional event queue system. You can tap this into those views. They were being exported to Prometheus, and then Prometheus was being connected to Grafana, and the system visualized in Grafana. If we have time, I think I will be able to take a look at this dashboard specifically for this project, okay? So this is how things started. And then, since this was used specifically to monitor transactional event queues, the idea was to say, hey, what if we make this general purpose and we create a whole set of exporters over the database to be able to monitor not only transactional event queues, but anything that is within those performance views. Metrics, logs, with also the ability to do traces, etc. So this is Prometheus Grafana for Oracle. It's the generalization of that architecture that I just showed you that provides observability in the form of metrics, logs, and traces for microservices. This is a Kubernetes-friendly environment, and it's using standard tools like a lot of developers are using them, like OpenTelemetry, Prometheus, Jaeger, Loki, and Grafana. Okay, so as I showed you before, we clone this repo, okay, and we already almost 10 minutes into the setup. So we need 5 more minutes before going to the setup, okay? So we clone this repo. Actually, we clone a branch that I created to fix a bug, but you will be able to clone this repo like probably 1 or 2 days from now and basically get that fixed. But this is also available in the container registry as a container image, if you're interested, if you want to have it as a container image. All right, so this is the graphic that I already showed you. So we see the Kubernetes environment exposing all those exporters from the autonomous database. And in general, how the system works is that they scrape what the exporters are publishing or putting out. Suppose that the metrics exporter is extracting metrics from the autonomous database. And this is not suppose, this is what's going on. Now the Prometheus system will be scraping those metrics and making them available within Prometheus. Prometheus is a time series database, right? So Grafana, if you go to Grafana, you can configure data source and add Prometheus to it. We will be doing all that, okay? All right, so I mentioned that we were tapping into performance views from the database. So these exporters that I showed before, specifically the metrics exporter, are using these views within the database to extract the metrics, right? So what are dynamic performance views? I'm not sure if you heard about it. You probably saw some $B$ views within the database if you're familiar with the Oracle database, or $GB views within the database. These are views that are continuously updated. They have performance-related content, for example, session information, weight information, CPU utilization information, all kinds of information. They can be selected from, but they cannot be altered directly. If you're familiar with Oracle Enterprise Manager, this is what Oracle Enterprise Manager is using to show you a lot of the metrics that you see within the Oracle Enterprise Management console. For every $B$ views, you also have GB$ views, and the G stands for global. So the global view is giving you that information, but for any instance within the RAC, the Oracle Real Application Cluster. So you will see the GB$ views have the same columns, performance information, but add an extra column for the instance ID. So basically gives you a definition of what the instance is providing that metrics information. They can each have their own set of columns. For example, $B$ sessions have a specific set of columns. It's different from what you would get from GB persistent subscribers, for example. And here, in the last bullet, I'm giving you examples. Like, for example, the second one, $GB persistent subscribers, is the one that is being used by the transactional event queue system to see what's happening with the subscriptions to those queues for the events. Okay? All right. So that's what's happening behind the curtains. Now, I told you that we use Prometheus to scrap the metrics, right, from the database. And these views, for example, in this case, I mentioned that the transactional event queue system provides information in that $GB persistent subscribers. So the system here provides a metric, and you can actually create your own metrics. And this one is called TX event queue. And it's basically SQL, as you can see. We are selecting account asterisk from that $GB persistent subscribers. So the more subscribers we have, this metric gets updated all the time. and the system will be picking this up, and the exporter will be generating the result of this metric, of this SQL, and the Prometheus scraper, which is the middle part there in this graphic, will be basically fetching that data, which is the result of this query, and making it available to Grafana. Okay, so it's as easy as that. You will see this metric within the project, but you can create your own metric. If you have a specific performance view that you're interested in and you want to create a metric, you can add an entry in the project with your own metric, and this will be automatically made available by the exporter to Prometheus, and you will be able to use it in your Grafana console, in your Grafana dashboard. All right, so these are other examples. For example, suppose that we want to tap into the $V session view. We can do a current session count, for example, by counting the number of sessions that we have in the session. We can do an active session count, which is the second part here, by tapping into the same view. Or we could do like a SQL query to actually calculate inactive sessions, which is the last part here. As you can see, we're flagging this as metrics, and we are making this available in the system too. And in this case, they are flagged as system metrics, but you can have all kinds of metrics. The previous one was flagged as transactional event queue metric as context. Okay, so enough of metrics. Let's take a look at the logs. Remember the three pillars: metrics, logs, and traces. With traces being the most complex things to understand. Okay, so logs. It's the same thing. We create queries that tap into the logs. In this case, we are tapping into the $dial alert view, which shows the context of the automatic diagnostic repository for the current container. And as I said before, Grafana log is like Prometheus for log. And if you see Promptail there, you see Promptail near to the logs exporter. Promptail is an agent that sends logs to logging. So it's like an agent that is running within the exporter to send this logs to Grafana logging. This example specifically wants to get the alert log for the orders database. Okay. Again, we're tapping into a $V view. Let's take a look at tracing. And tracing is a little bit more difficult because tracing spawns the application and the database horizontally. It goes from the app to the database, and it can go from the database to the app, right? So it's something that goes horizontally, but the app is usually not aware of the database, right? So we need a way to correlate what's happening within the application and what's happening within the database. There are ways to do this automatically. You can write sort of agents that will do this automatically for you, and that we are providing with this project. Or you can also, from the application, provide manual information that is related to tracing, and you will be able to correlate that and visualize that within Grafana. So in general, we have a Java application that is doing database operations as usual. We don't need to modify a lot of code if we use those, let's say, automatic agents that will be communicating with the tracing system. Or we could add some code, as I will show you in the next couple of slides, to actually provide tracing information manually, right? So you can run an agent, and we are done with this. Should be done with the setup right now. We will come back in a sec. But let me just wrap up the tracing, which is the last part. You are running a tracing agent. You can attach a tracing agent to Java. For example, there you can see Java agent and providing the char file. And this agent will be creating and obtaining traces, creating spans, et cetera, et cetera. And then you have a tracing exporter, which is the thing or the agent that will be sending those traces back and forth between the database and the Grafana dashboards and Jaeger specifically, and the application. So one example that I have here is the tapping into GB active session history. This code is a bit more complicated, but here we want to do is to trace an order spanning potentially multiple sessions by a user. So the code is tapping into the GB active session history, and it's using the CICD which is the execution context ID, to basically correlate the trace. So as long as you have an CICD, you can go all the way from the application towards the log. So suppose that in the logs you have specific CID, you can correlate that information, and we will take a closer look at that. Okay. So I told you that there's a way to, in the application, to actually manually send tracing information. So here you can see an example of explicitly adding tracing to a service using code. Okay. So this is Java code, this is the application, and what we are doing here is we're adding some baggage or application data to the span. And the span is basically a specific request within a tracing context, okay? So we need to say, oh, here something is starting to happen and we want to put this in a trace. So here we are manually updating metrics. This approach is great if you want to have a fine level control over your tracing, but there are other options that require no code changes practically. But sometimes you really want to do this manually within the application to say, hey, I'm starting a trace here, and I'm providing this information, and this is going to be great because it will allow me to go all the way to the logs or to the database and see what's going on. So at all times within the app, and you just need to add libraries that are part of the project to your Java application. At all times, you can access the tracer of resources like inventory. And this is something that you can see here in the code. Let me see where we are accessing the tracer. Here, I think that it would be the first line where we're saying inventory resource get tracer, right? So we are explicitly accessing the tracer. All right, so before moving forward, let's go to the demo, okay? So as you can see, you should get this setup completed, all right? And Violeta, can you confirm you see the Cloud Shell here?
Yes, we do.
Yes, okay, perfect.
Yes.
So we are done with slides, and now we are going to configure all of this, okay? So as I told you before, we have the infra. And let's see how we're doing with time. Okay, we have the infra. Now what we're going to do is we are going to go through lab number 2. Okay, so if you're following at home, for example, we should go through lab number 2. And what we're going to do is to deploy the GrabDish core microservices. These are Helidon-based microservices. So I'm going to cd into the GrabDish home, and I'm going to deploy the core services only, okay? As you can see, we're deploying the front end, we're deploying the orders microservice and the inventory microservice. Okay. All right. So let's wait a little bit. This is all YAML based. We don't have to do anything. We're just deploying the core services. So now we have microservices up and running. Okay. If we take a look at the pods, let's go and do that. I'm running kubectl get pods for all namespaces. You will see that we have, for example, take a look at the bottom ones, that we have the inventory Helidon microservices, the order microservice. We have the front end, which is super important. We will use the front end to actually create an order, show an order, etc. We are fine. So remember, we source that environment. And that environment gives me this, which is a shortcut for curlpod. We're going to run curlpod right now. So we're going into the pod, and specifically the front end pod, and we are going to create an order. We're going to place an order, okay? So for that, to do that, you have to do, we're going to use curl. We're going to provide the password that we created for the front end. Remember that I told you it was workshop 1, 2, 3, 4, etc., etc. I'm providing it here, and we are going to provide, and we are basically using the REST API over the microservice to say, hey, I want to place an order, and we're going to place an order for sushi, and we are saying the order ID is number 1, and we are basically hitting this front end microservice. Okay, so I'm going to hit enter. you should be getting this line, which is the confirmation that things went well, right? Order ID 1, sushi, etc., etc. Just in order to confirm things are okay, and we place that order, what we're going to do is run show order command. Okay, and the order is being shown, just the last line. Okay, so we are going to exit purple right now. This is fine. The microservices are fine. We can place an order, we can show an order. We're going to exit CurePod, and we're going to go to lab 3. In lab 3, we're going to install all the observability tools. Remember, Jaeger, Prometheus, Grafana, Loki, Promptail, etc., etc., etc. Fortunately, we have a shell script that does all of that for us. So I'm going to run that now. As you can see, we start with Jaeger. Because obviously we need to have Grafana within the OK cluster up and running. We need to have the different things that will allow us to connect to Grafana, all the data sources. We need Prometheus, we need Jaeger, etc., etc., etc. Okay, so we have the microservices. We have now, when this is done, we have the observability tools. What is it that we don't have yet? We don't have the exporters. Remember that we need to run a set of exporters that will read the database, will read those views, and will make them available to these observability tools that we are deploying right now. So the next step, when this is done, is to create the monitors and exporters, and that will be the final part of the equation. Okay. Now Loki is being installed. So this went well. Now, as I said, we are going to install the exporters themselves. So I'm missing a C there. Let's go to CD. We are in the same directory. The CD here is redundant, but in this case, we need to go specifically into the observability directory. That's why we're doing this CD right now. So this one is not redundant. All right. So we are deploying service monitors for microservices and PDBs. Remember, this is, let me see if I can show you. Let's wait a little bit. This is a specific.
Herman, we can, yeah. If you need just a quick break to take a sip of water there. There's a couple of, well, actually, there's some good questions come up in the Q&A, but there's a couple came up on chat. Can this framework be used for non-Oracle databases?
Yeah, that's a good one. Yeah, actually, if you use an exporter, like for example, there are exporters for MySQL. Actually, the one that is using this project is using is the Oracle DB exporter created by Seth Miller, which basically puts everything in Prometheus. There are other exporters that are almost identical for MySQL and for other databases. So yeah, that's correct.
Okay. I'll let you get back to your demo. I'll come back with the other ones the next break we have. Okay.
Okay, perfect. So we are done deploying the exporters. Okay. All right. So we are all set. Now we need to see, and we need to access Grafana and start configuring things within the Grafana instance itself. So let's do services. Let's take a look at the services. And what you want here is this IP. You will see when you list services that there will be one public IP. But it's the one for the load balancer, and it's the one I'm copying here. And what I'm going to do now is I'm going to do HTTPS .IP/Grafana. Okay, and I'm getting a potential security risk because we're using a self-signed certificate here. So that's why I'm getting this warning. I'm going to ignore the warning, and I'm going to say accept the risk. Okay, now I see Grafana. Here I have to do admin, and the password is from minus operator. From with an M minus operator. Okay, I'm not saving, and voila, we have Grafana. We are in Grafana, but now we need to configure things. So we start by configuring Prometheus, which is super straightforward. We go here to the gear, we go to data sources, and we just click here on Prometheus, okay? Here we will see that the URL is pre-populated for us. So we don't have to do anything. We don't have to enter any information here. We just click on test. And it works. We're connected to Prometheus, which is really good because it has already been deployed and connected for us. So we just hit back. Now we need to add Jaeger, okay? The Jaeger data source. And let's do that. Let's go to, and remember, Jaeger is for tracing. Go to add data source, we type Jaeger, okay? And here the URL is not pre-populated. I'm going to populate it for you. This is part of the live lab, but it's going to be the same for you. So just copy this URL, okay? Jaeger query, blah, 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 etc., etc. So I'm populating it. Now I need to click on save and test, and it should run. Data source updated, it's running, and I click on back. So we covered tracing and we cover metrics. Now we need to cover logs. Logs is a little bit more difficult to configure, but not so much, right? So what was the service that we were using for logs? It is Loki, right? Loki. So for Loki, we don't have the URL. I'm going to add the URL. Okay, okay. There you go. And we are going to add a set of derived fields. Okay, and this is so we can correlate information, tracing information with the logs. We need to understand what the logs are saying to be able to correlate things. So the first one that I'm going to create is going to be called trace ID for span reported. Okay. This is, remember the tracing code that I showed you where we were reporting a span specifically. So this gives us the ability to correlate those traces to logs. So we will call that name. We will look in the logs for the regular expression span reported, where we see a log that is reporting a span, okay? And we will add this as a query. Here we need to flag internal link and Jaeger. Don't forget about that. So this is the first one. And I have a test message here to be able to see if this is being parsed correctly. So I paste it here, and I should be able to see these values here. So this is being parsed correctly, okay? So it's basically, we are trying to extract the value for span reported. All right, we're adding one more, and that's it. And we are going to call this trace from ID from CICD. And what we're doing here is, this is for database log to trace correlation, okay? The previous one was for the Kubernetes microservice log to trace correlation. Okay, so we're going to call this trace ID from CICD. We are going to look for this specific pattern in the logs, which is CICD. We will try to extract the value, and we are going to use same we are going to do the same here, internal and Jaeger, and we're going to use the same query. Now I have another message here. To see if it works, and we are parsing it correctly, okay? So we should be done here. Let me verify that we have the URL, that we have the derived fields. Both of them are internal link, Jaeger. We have the regex, etc. Save and test. It works. Back. Okay, we are done with the Grafana configuration, but we now need the dashboard. Okay, we need the dashboard. So what we are going to do now is we're going to say, going to go here, I'm going to say, okay, dashboards, import. I'm going to import the dashboard via JSON. And we have it here. If you go, it's in the project, okay? So if you go to this URL, part of the microservices project. In the observability folder, we have a dashboard folder, and we have the graph dish dashboard. I'm going to copy all this JSON, which is the dashboard itself. and I'm going to paste it in the import via panel JSON, and I'm going to click on load, okay? And I'm going to click on import. And we have the dashboard, okay? This is really nice. Let's refresh. Okay. So as you can see, we have information for the front-end microservices, and here we're seeing the CPU load, heap sizes, etc., etc. We have a place order average time. We have information specifically to each microservice, like for the order microservice, we have a place order average time. We have a total number of orders by status, place order count, order PDB sessions. Remember that we have an inventory database and an order database underlying in autonomous database. We can, for example, quickly go here to autonomous database and see that they have been deployed as DB1 and DB2. If we go to Oki cluster, we see that we have our GrabDish Oki cluster up and running. Okay, so you should be able to see the resources right now. And we also have CPU load, etc., for each specific microservice, which is nice, and also a status on the service where the inventory microservice is up and running, what's the CPU load for it, the heap size, etc., etc. And we have like an event mesh general information where we're saying the order DB is up and running and the inventory DB is up and running. The moment the database go down, you will have something here that says that they are not up. And obviously, you can use Grafana alerting here to create all your alerts, because you now have the information within Grafana, so you can use the alerting system to actually do that. Okay, so as I said before, we have metrics about the Kubernetes microservice runtime. We have metrics about the Kubernetes microservice specific to that microservice, like place order, etc., etc. Just a quick recap. We have metrics about the PDB used by the microservice. PDB, remember, is ADB is within autonomous database. We call them the autonomous database instance. If you're using an Oracle database, the PDB is a pluggable database, okay? And we have metrics about the PDB specific to that microservice, all right? So suppose that we want to see if we have some modifications here. We can go back here, do curl again. So curl. Okay, let's create another order. And we only have like five more minutes to go, okay? Just to give you an idea, just so bear with me. I want to show you something important. We are going to do like not show order, as you can see here, but basically a place order. And we are going to place an order for Pixa. This would be our second order. Pixa. And we are going to do number 2. Okay. Okay, we have a second order. We are going to come here. And okay, we are going to take a look at, let's say, I don't know, last 5 minutes to give you an idea. Okay, we have a place order average time, etc. Now in 1 minute we should see, that other order. But what we can do right now is, for example, let me just refresh again. You can see place order count here. This is the one that we just did, okay? 1205. And we can do this, which is very interesting. We can go here and we can do explore, okay? And I just want to show you a little bit of the tracing functionality. We can do explore here, right? Now we are exploring the order PDB's microservice, the order microservice, and if we click here on split, we have 2 screens. And here we can say, okay, I want to take a look at the logs. This is Loki for the logs. If we hit here, this chain, we are basically saying, I want to see the same time span on the right and on the left, when I click on the chain. Now here, if we click on code, okay, we go to log browser, and here we click on app, and this is something some people think that this is not scrollable and say some options are missing. You can scroll here, and if you choose the order functionality, okay, and also the DB metrics order PDB, which is the database, the logs for the database PDB and for the orders, and you click on show logs, okay, you will see the logs here, but you will see that some of these logs have yellow and some of these logs have green here, okay? The green ones are the ones that allows us to do tracing and correlation between what's happening in the order service and what's happening in the database and in the microservice itself. So I'm going to look for the green ones, for example, and I'm going to take a look at order detail, for example. And if I click here on order detail, you will see this really nice Jaeger button here. And you will see the derived field that we created recently, the trace ID from span reported. And if I click here, this is an order that we place, okay? And if I click here on Jaeger, look at what happens. We are in the front end HTTP request for that order that was created. And we can actually go all the way towards the actually order being placed and take a look at, how many milliseconds it took, et cetera, et cetera, et cetera, okay? The order detail, et cetera, et cetera. So that is why it's really nice to have tracing in place and basically have tracing connected, so you can go from the logs to the service, to the database, et cetera, et cetera, et cetera. There are other logs that are specifically related with what's happening with the database. Like, for example, if we do back here, and this is the last thing that I'm going to show. Okay. Let me do back. And here we click on, again, order and the order PDB, show logs. For example, if you go here, you will see that this is something that is happening within the DB metrics exporter. The DB metrics exporter is doing a select. Remember how we generated these metrics by running SQL? It's doing a select to actually extract a specific metric, right, from a specific view. In this case, I'm not sure if I can see the view. Here, let me see if I can see the actual view. Oh, it seems I cannot see. Okay, but yeah, so that's what I wanted to show you today. We are going to do a follow-up session. Let me just go back to this view. So we are going to do a follow-up session in case you want to go deeper into tracing. Okay, and that's going to happen in the September-October time frame. But I hope this will be enough for you to be up and running and do your own experiments, and try things out by yourself. I hope this was useful, and feel free to ask questions in the Slack channel. I will be monitoring it. Okay, back to you, Violeta and Tom.
Let's see if we have any other questions that we didn't touch. Tom, anything else to?
There's one, but I think. I hope I'm pronouncing the chap's name all well. I think he's actually just booked a one-to-one session with.
Okay.
So I think we're okay.
Yeah. One thing is I saw a question where Olawale is saying, how can I pull metrics and logs to Prometheus and Grafana from an existing Kubernetes cluster? And I just answered, but he might not see it. You need to install the exporters in the cluster, like tracing exporter, logging exporter, etc. Obviously, if important if you are connecting to a database. Now, if you're not connecting to the database, this project is not for you because this is basically tapping into the database. But you need to have the exporters in place in the cluster, and that will be your entry points for Grafana, okay, for the data sources of Grafana.
Thank you, Herman. As you already know, feel free to join our Slack community, interact with us. Herman is there; he's monitoring the channel. In case you have questions after this call, don't hesitate to reach out to us. If no further questions, I would say we end this meeting. Thank you all for joining us. Thank you, Herman, again for being here and presenting to us. It was a pleasure again.
Thank you
We
to all the
hope to see
attendees.
you soon. Yeah, thank you all. We hope to see you soon again. Enjoy the rest of the day. Take care. Bye-bye.